what I'm going to do for the next 1 hour is, I know, I don't know how many of you know about WiNG5 or ever had a chance to play with our WiNG5 operating system, but over the next 1 hour, what I would want to do is get you guys familiar with WiNG5, and at the end of the day, talk more about, address a lot of these questions, what protocols WiNG5 uses, what are the services enabled by WiNG5. We'll talk about, the security, firewall, and all of that. And by the end of today, if you walk away with the thought that, WiNG5 is unique, I think I've done my job. So let's get started. Let's go, dive deep into WiNG5, right? So, sorry. Oh yeah, thanks, buddy. Okay, so as I mentioned before, one of the key trend that actually drove us to design WiNG5 was this growth of or popular trend of distributed enterprise, right? So as I said, with our older platform, older product set, there are a couple of pain points, customer pain points, right? And one of them was, inconsistent wireless service at every branch, right? So questions like, I have a remote site, I don't have a controller. What happens to my site if the WAN link goes down, right? I mean, can new .1x clients connect? Can clients stay on as they roam from AP to AP, right? So a lot of these questions started coming up, and that was kind of one of the key driver that drove us to design the WiNG5 architecture. And as I said, the WiNG5 code runs on every single wireless product of us, right? So you take the controller, you take the AP, you take the NX platform, all of it runs WiNG5 as a base operating system. So this is kind of a high, so this is going to be my, this slide is going to be the basis of my presentation, explain how WiNG5 works in distributed enterprise, how we enable service at the edge. So a typical distributed enterprise would look like this. So you typically have the NOC or the headquarters where you would have your management platform, you would have your application servers, where most of your IT would be situated. You could have multiple branch offices. A large branch could be a branch with, say, like 100 APs, right? And then you could have a small, medium branch with like about, say, 40, 50 APs, right? So you could have branches with different sizes, right? So what we've shown here is, at the large branch, typically we would have a local controller at the site managing the access points, and these controllers would in turn home back to the NOC controller and download their config, right? For a small, medium branch office, you wouldn't need a controller at the local branch. The APs would be talking to themselves at the branch, and then they would kind of home back to the NX9510, download the config. So you get a centralized management across all the sites, irrespective of the size of the branch, right?
Yeah, so at that small to medium, there is no controller. Not every AP comes back to the main branch. Just one gets elected as that so-called RF domain manager. So that one becomes what we call a virtual controller.
Okay, so let's look at let's start from. Oh, sorry.
I'm just curious as to when you elect that one AP as the RF master, and you said that anything above 64 was a memory because that's what memory utilization you found. Anything above there was terrible.
Yeah.
What happens in terms of performance for that AP as a local Servian AP up to 64?
Okay.
Are we starting to limit how many clients can connect to it, or is it better to maybe
okay,
just purchase
I'm just going to get to that.
Stuff it in a closet and call her good, no one's
Yeah,
so
I'm going to get to that
management
question.
Plane, right, so your data plane versus your management plane, they're two different planes. So it doesn't affect your data whatsoever, but there is a definite memory capacity, right, that we're going to hit on that management side, and that's where we just kind of limit it. So, is it a hard-coded 64? Is it a hard-coded 24? Right now, it is in software, right? But because we need to protect the process.
Well, that's what I'm saying. Is is it two separate systems on chips that are running this, where you've got, because even if the management plane and the data plane being put out separate ways, so the IPs, all their data goes local to them.
So we're going to
It's
address
close
that
to
in
utilization.
a slide, coming up. So I'm going to show up a slide where we show one AP homing back to the controller and say what service is run by that RF domain manager and why that 64 limit, 64 AP limit, and what would really happen to the data traffic. So if you just hold on to the question, and then a couple of slides, hopefully I should address that. Okay, so let's just look at how a typical branch would be deployed, right? So you have the NOC. Assume that you've configured everything on the NX9510. You have set up the branch policies. Everything is good at the NOC. You bring up the large branch, right? So when you start, plugging in all the devices, the controller and the APs, they come up with the default config, right? So they don't know about each other. And the first step is the controller to home back to the NX9510, right? So how does the controller discover who is controller? I mean, who is NOC controller is, right? So there are two options for controllers. We typically recommend configuring static IPs because you want to have the controller's management IP to be static. But we could also use DHCP options, right? DHCP options is typically used for the APs to home back to the controllers, right? So the NOC controller discovers the branch controller discovers the NOC controller over DHCP options or static IP. And as part of the setup process, the branch controllers could set up an IPsec tunnel back to the NOC controller, and this is optional, right? So typically what we've seen is if your branch site is running across a WAN link, right, then for security purpose we want to use IPsec. That's natively built into our product portfolio. But many of our customers use MPLS, so that obviates the need to create this auto IPsec tunnel. So that's completely optional. And this is the time I want to introduce something called Mint. So what happens is the controllers at the branch establish a Mint link to the NX9510. So I'm going to explain in detail what Mint is in a couple of slides, but just think of Mint as a communication protocol between the WiNG5 devices, right? Sorry?
Does it stand for something?
It stands for Media Independent Transport Protocol, right? So that's kind of, sorry?
Network.
Yeah, sorry.
It's CapWell.
It's Motorola's proprietary version of how WiNG5 devices communicate with each other, right? Like Cisco has CapWAP to communicate with each other. We have Mint, but it does much more than what CapWAP does. I'll probably explain those.
So
But
while you're on this slide, you're moving up from the small branch to the larger branch. If you had just to reiterate, if you had a smaller branch, you wouldn't need the branch controllers.
yes, you would need the branch controllers.
Any one of the APs would take that.
Yes, take that role. Yep,
Okay.
yep, absolutely. Okay, so
And by the way, is that automatic?
that's automatic. Yes, it's dynamic.
Well, I mean, from a sales guy, if I'm going to sell into which branch,
Yeah.
can I put in small ones and then at some point I get the flag that says,
Oh yeah.
you need more hardware, put in branch control.
So the way the RF domain manager or the site manager gets picked is the device that has the maximum processing capacity will get picked up as the RF domain manager, right?
All like devices.
Or if you have like devices, then probably the one with the least MAC address would get picked up as the RF domain manager.
So
But
you
it's
could-
automatic.
You could just buy like, I don't remember what you called it, like a super AP that has
Yeah.
a controller plus an AP.
So all
I mean,
APs
it's-
are super APs, right?
Yeah. All the exactly. Yeah.
But don't you have one that has more processing power than
It does.
Yeah.
It does.
So you
It
could
does.
kind of stair step from a smaller AP to a bigger AP and then to a controller
Yes.
and then,
It does, yes, you're right, yeah. So, okay, so you create a Mint link. The branch controller creates a Mint link to the NX9510. So for now, think of Mint link as the underlying protocol for a WiNG5. That's a protocol that we use to communicate between WiNG5 devices. And then they download the config, right? They download their branch specific config. Once they have the config, they're going to form cluster with each other. They're going to learn about each other. and one of them is going to get elected as the RF domain manager, right? And again, so I'm introducing a new word called RF domain manager, concept called RF domain manager, and again, I'm going to talk in detail about RF domain manager, but think of RF domain manager as kind of the site manager, right? So one of them is going to get elected as the RF domain manager, and the other controller, they tear down their IPsec link back to the NOC controller. So at this point in time, you have only one device from the branch which has got a communication link back to the NOC controller. Okay, so we'll explain why, and the next step is the APs come up. You plug in the APs. Since the controller is actually in the same L2 domain, they automatically discover the controller, or you could use DHCP options. They get adapted to the branch controller and they start downloading the config, right? So at this point in time, you have a site, a large site, where the local APs are managed by the local controller, and all the config, you get full visibility of the entire site from NX9510, right? So in a sense, these controllers are adopted to the NX9510, managed from the NX9510, and these APs are adopted to the local controllers. Okay. Sure.
So there will always be a master AP in this situation by election.
Yes.
And there always will be a standby. If the master is going down.
Gone down.
How is that selection made?
So the selection is made. So at a branch, the device with the maximum capacity or capability in terms of hardware gets picked up as the RF domain manager, right? And if you have like devices, then I think the device with the least MAC gets selected. And then if that goes down, we detect that the RF domain manager has gone down through Mint protocol, and then another device automatically gets elected as the RF domain manager.
The election process happens automatically.
Yep.
So if the RF domain manager gets hit by a forklift truck, right, in a warehouse, whatever it is, right, another device will just take that role. And it's a pretty quick convergence time, typically within a matter of a couple of minutes, new RF domain manager's up and running, that's being aggregated back up to the data center.
Sure.
So across this WAN link, how much traffic would one expect in a normal situation? Because all the traffic's still being dumped locally.
Yeah.
So if I were to sniff that traffic, what would it be?
Okay,
Is it
so
control traffic, is it images being pushed across? How often does it talk?
okay, cool. Very good question, right? So in this architecture, as I said, we kind of push all the servers right to the edge, right? So I know some architecture where you have to go back to the controller to do a lot of your services like RF management, right? You want to do interference detection and recovery. That engine is actually on the controller, right? And what that means is the AP is constantly scanning the RF medium and sending a lot of stats back to the controller. In this case, that server is actually pushed to the edge, right? That functionality of RF management is running on the RF domain manager, right? So that stats is not going back to the NOC, right? The only probably thing that is going back to the NOC is at the NX9510, if you say show wireless client, right, at branch 1, right, there's a statistics pool which comes back as an aggregate statistics. I'll talk about this. And then the other traffic that you would see is link is packets to maintain the links, right, between the NOC and the branch, right? And then there is going to be some routing information that's going to be exchanged between the branch and the controller. But since most of the servers actually push to the edge, it's very, I would say, compared to a controller architecture where you run all the services to the controller, it's very less.
So your typical bandwidth, so most of my customers, in the 50 AP market, remote sites, measuring it from like an AMP module, something like that, typically 4 to 6K.
Okay.
It's about average. So it's very, very small. And even firmware distribution, which I think
Oh yeah, we're going to, yeah.
We have a way to optimize that as well. So
Yeah.
it's pretty
So with the two controllers here, are they essentially acting in I guess, what I'd call a true high availability? Is that how they're set up in that there's sort of one management address IP shared across the two of them?
We could do that. We have VRRP inbuilt into our controller, so
In this
it
example,
could
it's
do
an
that.
active standby,
Yeah,
right?
it's an active standby in this
In
example.
this example, but it could go active with VR.
Yeah.
Sure.
Between your active and your standby, are they communicating any kind of information about states, sessions,
Yes,
things like
absolutely,
that?
yes, yes. Not just the controllers, right? Even the APs are talking to each other about the client sessions, right? So I'm going to, in the next couple of slides, you'll also see what is being communicated across access points, across controllers. So we maintain the state of the clients.
How do you talk to each other, like through the air or through the?
It's so, as I said, it's meant, right? As long as an AP can talk to another AP over air or through your wired port.
So are these wired?
Right? Yeah. I mean, this
In
could be
case,
wired.
It's not a mesh, right? It's
I mean, it's not a mesh. Yeah, it's not. I mean, in this case, yeah, it's wired. All these are wired.
But it could be.
It could be a mesh.
okay.
Yeah,
Absolutely.
because Mint is going to run on top of your wired or your wireless mesh, connection.
Okay.
Is
So-
the mesh protocol still is it proprietary, or is there any move to
So
802.11s?
our
It's
mesh
still
protocol
he's a
today, we have
mesh
two different
expert.
mesh. We're also hub and spoke, which is proprietary, as well as our full mesh architecture, which is proprietary protocol today.
I don't really think anyone's moved to 802.11s.
No, not yet. Right.
Sort of too late in the game then.
You know,
So,
for efficiency and device management as well as device awareness, it's almost easier to stick with a proprietary protocol.
Sure.
Okay. Sorry. Is that? Oh yeah. Oops. Sorry for the bad. Oh, okay. Here you go. Okay. So the next step is once the AP gets adopted to the controller, the next step is is for every device to discover every other device in the branch, right? In this case, what happens is, since your devices are on a single layer 2 network, they just send a broadcast and they learn about each other, okay? And then what they also do is they create a Mint link on the VLAN that the APs deploy, okay? So over the Mint link, every AP will learn about every other AP in the same site, right? So it will build its neighbor table, and what that does is, it helps exchanging information that are critical to enable some of the wireless LAN services, right?
Now
So
it's an architecture.
now, if you look here, as I explained earlier, it's the RF domain manager alone that maintains the Mint link back to the NOC, right? So in this case, what happens is these devices, they don't have any clue about the NOC controller, right? They're not going to discover the NX9510 as a neighbor. It's this guy that's going to maintain the neighbor status with the NOC controller, okay? And that way, it helps in kind of reducing the number of route packets being broadcasted to across multiple sites, and kind of the RF domain manager kind of acts as the gateway between branch sites.
So are you saying that the local Mint link is layer 2 only? Can they be across the subnet boundary?
Yeah, it can. I mean, it can be. Yeah, but you just have to. Yeah, Kevin.
Yes, I think it's one thing I think we kind of, so Mint is medium independent, right? So it can operate at layer 2, right? So directly between devices, that could be controller to controller, AP to AP, AP to controller. That could be over IP as well, right? And obviously the medium over IP could be anything. That could be Ethernet, that could be a WAN, MPLS, mesh, whatever that might be, right? So, from an AP perspective, I think we're probably still one of the only vendors that offers layer 2 adoption still, right? So management of APs at layer 2. So our AP, the architecture is very flexible. So we can just drop an AP on even just an IP-less environment and have those managed by the controller.
So how does a local AP
Yeah.
discover other APs using Mint across a layer 3 boundary? I mean, layer 2 we all understand that's pretty easy to hit,
Sure.
but how does it find them on the rest of the network?
Is it doing
So,
Bluetooth lookup?
okay, so in this case, right, typically what we would do is, at least in most of our customer scenarios, let's take this example, right? This network is on a separate VLAN, and your NOC is on a separate subnet, right? They don't have any visibility, right? So what we do is we create an explicit mint link. Okay, so as part of the adoption process, he is going to create a mint link back to the NX9510, right? And now if he has any traffic that needs to be routed to, say, an AP across a different subnet, his default gateway, mint gateway, is going to be this RF domain manager, right? And once it goes in there, he knows that to get to this site, I need to send it to him. So they don't learn about APs on a different subnet directly, right? But it's across the RF domain manager,
To answer your
routes.
question about layer 3 adoption, right? So we first go out and we'll look layer 2, okay? If we don't see a controller via layer 2, we can either have it hard-coded, right? The controller is at this IP address, push that down, or we utilize DHCP options, right? So typically it's a DHCP option, so based off of those options, it's going to tell that AP what IP address the controller is at, that's where that happens on that layer 3.
Yeah, and exactly right. So if I just take the large branch alone, I mean, so assume that you split the site into 2 subnets. What's going to happen is the APs are going to adopt to the controller anyway, right? And the APs will have a mint link back to the controller, right? So in that case, your controller is acting as a mint router between the two subnets. Okay, so they create mint links. The RF domain manager maintains the neighbor status with the NX9510, and then they exchange information. Okay, so let's look at how a small medium branch deployment would look like. Very similar. I mean, there's absolutely no difference in the way, from an architecture perspective compared to the large branch, but just that in this case, it would be one of the APs that picks up the role of the RF domain manager, right? And then as you can see, he's the only one that maintains the mint link back to the NX9510, okay?
And it's
I know-
capable of doing an IPsec tunnel.
Right, it is capable of doing IPsec now if you wanted to do IPsec across branch, yeah.
we see a
So
lot of
IPsec is natively inbuilt into the APs.
Okay, so if I'm in a scenario, say I'm at the large branch and for whatever reason we only have one branch controller
Yeah.
and it goes down, will they automatically know, okay, we need to elect an AP to be our temporary guy, or are they just get?
Yeah, he would. An AP would automatically pick up the role of RF domain manager. Okay, so here's a catch, right? So our documented best practice, or the number that we can scale for a controllerless branch is 64, right? And we have good reasons to believe why it's 64, right? It's not because of because we can't push service to the edge, but there are some other reasons which I'm going to talk about, right? In my lab, I have run sites beyond 64, and and got it working, right? But as I said, our documented number is 64. So so if you kind of go beyond 64, we don't guarantee the performance or how the network would behave.
So if RAM drops in price, does that mean you can increase the capacity?
Yeah, absolutely. I mean, we are looking at doing that already.
You have to have a number you're willing
Yeah.
to support, right? But
Draw a
strictly
line
from a
in the sand.
support perspective, you guys say, hey, look, we're not gonna support it if you're gonna push it, because we're not gonna test it beyond that point or whatever,
Sure.
and we gotta move you up to the next step.
And physically, when we look at an RF domain, look at it as just an area of coverage, right? So typically, if I had 64 APs
I want to
in
show
my
the
enterprise,
CLI. No.
not necessarily are all those 64 APs aware of each other, right? So you might want to look at the architecture and say, okay, this half of the building, the APs would see each other, and in this half of the buildings, the APs would see each other. I'll have 2 RF domains. And in that case, I would have 2 separate RF domain managers. So
A better example might be a campus with 2 buildings, right?
You know what?
And that
Maybe we
RF
should just
domain
address
is
that
very
right now.
because I don't have to look at, when you look at
I know there's been a
the
couple of
combination
questions around. Let me just step through this. Sorry for this, but I want to address this before we. Sorry, guys, but okay, here we go.
But real quick, on that subject, if those 2 RF domains do touch,
Mhm.
what does is there any client impact when they go from one domain to another? Is there a layer
Right.
3 handoff? Can they be on 2 different layer 3s? Like maybe one building is 192, the other building is .10. How does that architecture handle a layer 3 mobility run?
Okay.
Actually, he's getting ready to
Okay,
go.
great.
Get ready, right?
Yes. Okay. So first is, there's been questions around why we have the 64 AP limit per controllerless branch, right? First is APs have limited memory, right, and limited CPU, right? And one of the unique things, that's very unique to us in the way we designed WiNG5 is the way we handle statistics aggregation, right? So if you look at most of other competitive architecture, the way they do statistics aggregation from different APs is every AP would start sending stats back to the controller, right? So every AP is creating that link back to the controller and pushing stats. So so at the controller, if I do say show wireless client at say branch 1, what happens is every AP starts sending stats back to the controller, and the controller shows an aggregated stats. We do it a bit different, right? The way we do it is the show wireless command stats go to the RF domain manager in that particular site. And what the RF domain manager is going to do is he's going to get a consolidated stats of that site from all the APs at that site and send back a single packet of consolidated statistics back to the NOC, right? So so we found that was one of the though that feature kind of enable a lot of flexibility, we could save a lot of WAN bandwidth. The stats was more real time. Because instead of pulling it from every AP, this kind of we tend to get it real time from one AP. But yes, I mean we hit the limit of 64 APs per controllerless branch, right? If I remove this, if I in my architecture, if I said every AP is going to talk back to the controller, then I don't think there's a limit at all. We could just kind of scale, but yeah, I mean it's just. I mean, truly, this is our recommended architecture for all of our customers. If you have more than 64 APs at a site, have a local controller. I mean, from an architecture perspective, it's so flexible. But you could always do the multi-RF domain type as well. And to your question, yes, I mean, what happens is again, the RF domain manager, they kind of, become the routing entity within each RF domain, and as clients want to talk to each other, they get routed through the RF domain manager.
Right. So the main access point, if you will, is handling a lot of that.
Right. Yes.
So like pairwise master keys and maybe all that would live there.
Okay. The PMK cache is getting raw. I mean, so the way we do PMK cache is it's not one AP that holds the PMK cache for all the clients on the site, right? So when a client gets associated, he does .1x, does the key exchange.
Sure, right.
The PMK ID is sent to all the APs in the site, right? It's sent to all the APs that has that specific VLAN.
So if I have 2,000 clients, you're going to have 2,000 keys.
Right. So that's why it's kind of, we would say for large site, you kind of beyond 64 APs, it's more recommended to have the controller at the local site.
So effectively, you're doing like a sticky key.
Yes.
Kind of,
I mean, yeah.
when you
Hey,
talk
Kevin,
about
do you know
2,000 keys, I don't believe
do you know how many keys can the AP hold? I thought it was more than about close. It was a big number, I guess. I don't know if maybe we can get, but I know it's a pretty decent number.
How many RF domains can you have in controller?
The NX9000 can do 4096 RF domains, 4096, 4096.
Okay.
So that means you can have 4096 different sites. The NX9500.
That's a bigger one. That's
Yeah.
a bigger one, right?
That's the biggest one. Yeah.
And that's actually going to be increasing soon because we do have customers that have single
AP
cell
sites.
So that should be increasing very shortly to 10,240, right, which is what we can support on the larger controller.
So we're going back
I'd
to
like to ask again, if everybody can please speak up. We've had some comments online that they can't hear you.
Okay.
okay, Steve.
What was that again?
About a very distributed site architecture where you have like a centralized data center, say, that has no APs in it, but all of your APs are ones and twosies out of the sites.
Right.
Would you still recommend to have the NX500 being the master? For
Yes, yes, that's what we would recommend, and it goes back to what Kevin says. A lot of our customers have these single AP, 2 AP sites, very small branch offices, and we are looking at kind of increasing the number of RF domains that can be configured on the NX 9000 from 4096 to say close to about 10,000. Yeah, that's the architecture that we would recommend. Yep.
So,
Sorry.
you fir- or you wanna go first?
I'm just going to go back to the
Back
slide.
to George's comment though, on the keys and how that's all handled.
Yeah.
You kind of glossed over something that I just did the quick math on. If you're saying that I've got a site with 2,000 clients on it, you're saying I should push a controller, but we all know our customers aren't going to do that. The customer's going to look at it from, okay, if I've got 2,000 clients and I can have 64 APs at a site, that's 31 clients per AP. Are you telling me that you can't support any more than 31 clients per AP?
No, I mean it's again the question of stickiness, right? I mean we would still, I mean, so just like how Apple does roaming, so every AP goes. I mean we had everyone had this problem, right? So every AP that Apple device roams to, he creates a new PMK ID, right? And then at one stage, when you come back to the old AP, the old AP has kind of lost its PMK because he never roamed. He roamed to like 20 other APs, right? So that's kind of stickiness, right? Probably, so in this case, we will hold like 2,000, PMK, whatever that limit is. I'm not sure what that limit is, but we could get that number. But and if like say 2001 number client comes in, we'll probably clear off the oldest cache, right? Okay. So that's what we'll do it. But yeah, I mean it's I don't think there's going to be a limit on the number of clients per AP.
Is there a limit on number of clients per
AP?
RF
It's 2.
domain, RF domain.
It's none I'm aware of. No.
Not that I'm aware of.
It's actually documented, I think it's actually a how-to guide. Oh, sorry. I think there's actually a how-to guide that we have posted on our support site that has some numbers, general scaling numbers for the distributed deployments. I've got it somewhere, I just don't have it right with me. But yeah, we have a recommended number that we have documented. But I think the AP, the general AP limited is what we have, 256, but even that's not a hard limit, right? That's a general recommendation.
I know a site where we have like close to about 50 APs and more than 1,000 clients connected to it, and we've never had any issues with. And they do PMK and roaming. These are like handles, so running voice, so they roam often, and we never had any issues.
But realistically, we're like every other vendor in the industry, right? It amounts to how much bandwidth you have and what the service level agreement you want to give to your customers, right? So that kind of limits what you want to put on the AP.
Yeah.
Right, and we always have that layer 1 limitation as well,
Right.
right? Of course. But back to the PMK cache, and I'm not hooked up on it, I'm very interested in it. Is so I gain my PMK. Does that automatically go out to all the APs,
Yes.
or when I associate to my next one,
No.
it moves to the next
Okay.
access point?
Great question. This will answer it. So this is how we do it, PMK caching, right? So you have a site. Assume that your WAN is down. Your controller is at the NOC, but assume that your WAN is down, and assume that your local, you do PSK, or you do like a local radio server, right? For sake of argument here. Client 1 comes in. He does an EP exchange. He does a key exchange, and at that point in time, the AP1 sends its PMK ID to all the other APs through Mint, right? So every other AP will know the PMK ID of that particular client, because PMK ID is going to be critical for roaming, right? Because that is the one, you don't want to wait till you get connected to another AP and then him querying the first AP, right? So yes, the PMK ID is pushed, right?
It's almost like broadcasted out.
Yeah,
Right.
across a Mint, and that's how. So these are some examples of Mint enable some of these services. I mean, there's a lot more, but I have like a couple of them just to get you guys understand what Mint does and how some of these features work.
Dan, did you have a question now?
In your example,
Hey Dan, sorry.
Well, that mostly answered it actually, but I have another one.
Okay.
I can think of something else. Just so I make sure I'm not making assumptions around how you do it. When I'm doing authentication, say I'm doing 802.1x some kind, right? I've got a radius. What's acting as the authenticator here? Is it the AP itself, or is it your RF domain manager?
So it could be, so your proxy, so there are multiple ways, right? You have the AAA server at the NOC. You can say my proxy is through the RF domain manager or through the controller, but the authenticator itself is actually your client. I mean, it's the AP itself.
Is the AP?
Yeah.
Okay.
Yeah, we're flexible. We give you the choice, right?
Yeah.
So some customers want the access request to originate from the AP, right? Especially in a branch environment. Some customers don't want to have to put all those NAS entries in on their radius
Yeah.
server, right? So they'll just use the,
On the controller.
controller, right? You know, I'm lazy, so that's typically where I like to do it. But we do give you the flexibility of doing it through the RF domain manager as well. And it's all how you want that to, you know, come into your AAA server. And the nice thing is too, from an architecture perspective, we try to be a little bit more intelligent. So we give you the ability to do based on DNS or IP address, and up to 6 server entries as well. So we can, you know, hit a load balance. We've got some customers that use geo or you know, geographic or local load balancing. So you know, we can support those scenarios as well. Which is, we try to put a little bit more intelligence in the 5.0 for those larger deployments, which is nice.
And I notice up there it says, you know, OKC when controller is down. So when a controller is up, opportunistic key caching is in play, I'm assuming?
No, so the feature is OPMK caching when the controller is down. So typically in the earlier architecture, your OPMK cache is stored at the controller, right? So when the client roams, the controller sends the PMK to the AP that the client roam to. But what I'm saying here is we don't depend on the controller, right? Again, it goes back to saving those WAN bandwidth at the local site, right? So we don't necessarily have to send all those PMK cache back to the controller and query the PMK ID for the client. So it's completely self-sufficient. So if you notice here, I bring the WAN down, right? That means your controller is out of your data control path, right? Even then, I can the APs exchange the PMK IDs amongst each other, kind of pushing the OPMK back to the into the AP.
And what about future support for 802.11r?
Yes, good question. We're doing the same way. So we will we are getting it in the next bill, and we'll do it in the same way. You wouldn't have to have the the R0 keys at the control. I mean, they'll be kind of pushed to all the APs. It'll be completely self-sufficient at the branch, self-contained at the branch.
That's the future. That's the future release, right?
I think it's going to be in 5.4.2. That's probably coming up, but I can actually get.
So you don't hit to support today for 802.11r, or you do?
I think in the current release we don't, but we have a beta code that's already out there, which does 11R, and I think it's yeah. It's not too far away. I think by the end of this month, or the beta code is already out there. But yeah. Okay, so this is how we do PMK ID. So as he roams, he just does the key exchange, and kind of gets rid of the heap exchange. I know I'm running out of time, Vic, but just give me like 2 minutes. The other cool feature that we have. Okay, so like another example of WiNG5 service at the edge, right? Peer-to-peer, block peer-to-peer communication, right? So if you enable block peer-to-peer communication on a wireless LAN, typically if you have the clients connected to the same AP, assume that your WAN is down, it's a no-brainer, right? Your communication is going to be dropped. But what WiNG5 really does is, as I said, the client information is exchanged between APs, that it knows where the destination is, and even if the clients are across APs, we will drop the peer-to-peer packets. Just another example of service that Mint enables for you. This is a cool feature that we have. So I know someone raised a question about stateful firewall. Yes, we have L2, L3 stateful firewall on the AP itself. For example, right? Let's take an example. You create a rule. Assume that you have a client, you have an FTP server. You create a rule which says allow anything from the client subnet to the FTP server, but then you don't create any explicit rules on the way back, right? So if it's not stateful, you should have dropped the session, right? But in our case, we will get the session established that shows it's stateful firewall. Blah blah blah. And then the cool thing is, even if your WAN is down, right? I'm just making this claim. Even if your WAN is down, what happens when your client roams from this AP to this AP, right? So in this, assume that, okay, I think there's the next slide. Oh yeah, sure. So assume that there's a FTP download going on AP1, right? And now AP1 has the flow information for that particular session, right? And AP2 doesn't have a clue, right, on what ports are open, right? So what happens when a client roams from AP1 to AP2? So what we do is we have this cool feature called firewall flow migration, where the AP2 queries the firewall any existing flows for that particular client, and AP1 sends all the firewall flow information back to AP2, and so that way your FTP still continues. So that's pretty kind of pretty cool feature that we have, where at the remote side, even we again, right, we don't depend on the controller for this. It's all enabled over Mint.
Sure sounds like these APs are chatting a lot.
Yeah, I mean
how much bandwidth are they kind of sharing between each other? I mean, it doesn't sound like a whole lot, but it sounds like they're moving keys, they're moving rules.
The keys are not much because it's broadcast, so it's going to go to everyone. Two information that gets that gets communicated every time a client connects are the PMK ID. That's even before he roams, and the VLAN ID, so that he knows when using VLAN pooling, he knows what VLAN to put him on. This is kind of a pull information, because once he roams, then you migrate the session, right? But other than that, it's the PMK ID and the VLAN is the one that kind of gets. Do you see anything else that typical?
It's dynamic, right? It's if I have a lot of movement going on, there'll be a lot more man.
So is best practice to put the APs all in their own separate VLAN, separate from all other traffic?
The management traffic, yeah, absolutely, yeah.
Now going back to the beginning, this is a license feature? This is
No, this is not. So as I said, the L2, L3 stateful firewall comes with your native WiNG5 operating system, right? Okay. The only thing that's licensed is if you wanted to apply roles to, say, user, to different sets of users, like IT and admin and marketing and sales, or so the L2, L3 stateful firewall comes as part of the native operating system. Okay, great.
I just have one more question.
Sure.
For this, I forget what you called it, the
stateful firewall flow migration.
Transfer between the APs. What's the latency like? Like, how long does that take from one AP to the other?
It's not much, actually, because I think what we do is we do predictive roaming, Kevin. I know there's been something weird.
I think it's done with the flow migration, right? So as you're sending the
roam
notification is generated, I believe.
So
when you do our authentication
packet in an FTP, right?
So
yeah, it's fine for FTP, but what if I'm like, I don't know, I'm Skyping or something?
Like voice, yeah. I would say, the only thing is it's definitely better than dropping that session. The other option is if you didn't have the for firewall flow migration, it's but I don't think it's noticeable, because I've run this voice test and FTP test with session flow migration, and I think the way we do it is when he gets an association request on the second AP, the client kind of the AP kind of queries other AP or sends a notification saying that I have this client coming over, and the AP that has the flow kind of sends over the flow. And I know we are looking at improving that, saying is there a way to kind of do a predictive roaming. And
can you touch shortly on multicast? Does multicast go out to all the APs and then get dropped, or does it go out to the specific APs for clients that require or request multicast traffic? Okay,
so we have this feature called IGMP snooping, where
what's it called?
IGMP snooping. Okay. So we maintain an IGMP snoop table. So for example, you have a list of clients listening to a multicast video stream, right? And so the AP maintains a list of clients that are really interested in that traffic, and if an AP is not, if he's not even, if he doesn't have any clients, exactly, we don't even push it over to the air. We don't push it over to the air.
So by default, we try to maximize the airtime, right? So multicast and ucast, set up your IGMP, but yes, we can set up natively multicast across all APs, which is detrimental on the wireless, but absolutely.
A lot of that's going to be dependent on how you're bridging your traffic too, right? So if your APs are bridging their traffic locally, then it's going to be a combination of your wired infrastructure and the AP infrastructure, right, to participate in that group membership exchange, right? Tunnel traffic through the controller, then the pruning happens at the controller, right? That's a slightly different mechanism that's going to be required there.
So am I understanding it correctly that you're not doing a totally distributed data plane through just having each of the APs do data control and just sending management packets back to the controllers?
So we give you flexibility. I mean, so you're talking like the data plane is either local or, but we give you the flexibility to do both. So again, we're not trying to, with WiNG5, we're not trying to lock you into one architecture, right? So typically in the past, it's been you got a controller, everything that data plane's on the controller, right? Everything's tunneled to the controller. That's the typical mantra, right, of the past. If you got an AP, right, standalone AP, everything's bridged locally. We give you actually the flexibility. I don't think we've really touched on this. With the Mint architecture, so Mint is management and control and data plane, right? It can do all three of those functions. So if you want to tunnel the traffic to the controller, we can do that. If you want to bridge the traffic locally, we can do that. If you want a hybrid model where you want to tunnel traffic even between APs, as long as there's a Mint link, right, and that could be over a VLAN or that could be over an intermediate IP network, we can do that. So it's actually, from a data forwarding perspective, there's a lot of flexibility as well.
Yep, sure.
And not to get ahead, but are you going to touch on IPv6 at all?
No,
What
not
WiNG5 can do with it?
no, not today.
Okay.
We like NAT. Oh wait, Tom's not here, so.
We don't have any
Zero
Provisioning?
Yeah.
Vic is going to talk about it. Yeah, I don't want to steal his thunder. Okay, so Kevin mentioned that the Mint enables you to deploy any architecture that the customer wants, right? If you wanted to tunnel all the traffic back to the controller, Mint enables it. If you wanted to, locally bridge, that's possible too. And if you want to do a combination of both, that's possible too. So that's kind of one of very unique things about WiNG5 is no matter what architecture your customer wants, our customers want, we can enable with WiNG5, right? For example, right, we've been talking about distributed edge, but this is another classic example. A lot of customers still like the concept of not exposing your wireless VLANs on your wired edge, right? And we have some, as I said, Mint enables some cool features or cool routing there, where assume that you have a wireless network on VLAN 20, which is not even exposed on your wired network, right? And assume that you have clients talking to each other. Is it? Oh, why? Okay, sorry. You have clients talking to each other on VLAN 20, like say peer-to-peer voice. We can tunnel using Mint. The APs can detect the best or the fastest route and send the traffic to the AP without even having to go back to the controller, right? So that's like one of our unique differentiating.
So the takeaway from this is VLAN 20 isn't down in the infrastructure, and we're also not tunneling it up to the controller, but we're using Mint to tunnel directly to our shortest path.
Okay. So same way if you have a wired printer, we could well do it.
We see, I see a lot of this stuff in the higher ed, or even at the high school level, where football stadiums. Can't tell you how many people when you see a printer at a football stadium, across a mesh link or something. So we're extending that VLAN across that, special network. Or even another analogy would be look at the point-to-point communications from the dugout to the bullpen. Right now, you can set up a unique network there.
I think, again, think of cat WAP, LWAP, right, tap out, depending on what vendor you are, right? They're all pretty much point to point, right? AP to controller, right? Those are the tunnels from AP to controller. What we're adding is the element to say, what, the tunneling Mint can be, again, AP to controller, AP to AP, or AP to controller. So we're just giving you that, again, extra layer of flexibility.
Yeah, I would say, between any WiNG5 device, right? If you could have your, I don't know, probably even any other network element, if it could run Wing, if we could actually create tunnels and get the devices to talk to each other. Okay, so
Quick on that subject. So literally, you can have on a Cisco infrastructure, they have a guest controller, right? So you tunnel guest. So the guest packet the native packet itself never touches the switch fabric.
Right.
Beautiful thing, right? So effectively, you could do a tunnel right from, let's say, from AP to AP, to provide an inexpensive guest solution.
Absolutely, absolutely. We actually have customers doing that. So we have customers that, for example, maybe a perfect example, a site that's maybe 50 APs, let's say, and they'll have an RFS 4000 controller there that's connected to DSL, DOCSIS, whatever that is. He's doing NAT, doing firewall. All that guy touches is the guest VLAN, and we're just using basically Mint to encapsulate that guest traffic to the RFS 4000. He does the captive portal, the admission control, and NAT firewall for the internet, and that's a pretty common way to do that. And the only thing from an exposure perspective is we have, it's either a VLAN link from the APs to that RFS 4000, or it could be an IP-based Mint link as well. But basically, as long as it's a VLAN, the APs can reach that controller over a VLAN, or the APs can reach it over IP. We can tunnel that traffic.
What can you do with an AP though?
Yeah, absolutely. So for a perfect example is an AP 7131, which I think we have one in that RF chamber down there, 2 gig E-ports. So yeah, that second gig E-port, I could have that connected to an external public network. He can do my NAT firewall, good to go.
Question here, let's say I have a small branch with 64 or maybe less APs. How do I upgrade the software?
Okay, cool.
Push
Okay.
the software on the master or
Yeah, sorry. Okay, that's. I think it got lost between the slides, but so what happens is, as I said, we have built in some optimization around firmware distribution. So when you want to do an upgrade to the remote site, one copy of the firmware is pushed to the RF domain manager, right? Just one copy, right? And the RF domain manager in turn is going to distribute the firmware to all the other APs in the site. So instead of having all 50 APs download the config from the NOC, which is going to choke your bandwidth, the RF domain manager just downloads one copy of the firmware, distributes the copy to all the other APs in the branch, right?
let's say I just have a small branch. I don't have any. I don't have an HQ. Is that feasible, or do I still need a controller?
You'd still need a controller to. Okay, no. Oh, okay. All right. Yeah. So you just have a standalone site without a controller. Then we have something called virtual controller. I mean, I didn't bring that into discussion here because it's more suited for very small branch offices like say 24 APs. Then the controller functionality is actually on the AP, right? But that's for sites less than 24 APs. I mean, we usually don't recommend that for like large sites, but that functionality is available. Yeah. So, yep. The AP is.
RF domain manager gets a controller code, right? He pushes it out to whoever's connected to him, right? He's going to be the guy who pulls all that data from the NOC, gets it, then he'll distribute it locally. From the standalone virtual controller, that virtual controller, the AP that acts as a controller, would then push this local to him. That's it.
Yeah, so there's a reason we distribute the firmware out of the RF domain manager. And if you think about it, our average customer probably has several thousand remote sites, right? That's typical customers that we deal with on a daily basis. You can think those sites have probably anywhere from 30 to 60 APs per site. A firmware upgrade is, not an easy process, right, in a traditional controller model, right? So if you think that a controller, an NX controller can upgrade, let's say, 30 RF domain managers simultaneously, and each one of those RF domain managers has up to 64 APs that it can distribute the firmware up to. That's a lot of simultaneous AP upgrades, right, that we can perform versus doing those independently. So there's a lot of, there's not just a WAN optimization benefit there, but there's also a significant time optimization, right, for when performing those upgrades. So a site upgrade now is going to take me, 30 minutes. So I did a customer before Christmas, and I think on average it was about 25 to 30 minutes to upgrade your remote site over the WAN. And they had several hundred sites, and we were done in a matter of 2 days versus 4 weeks. It was significantly faster to do it that way.
Can you stage the update so that you could say
absolutely.
at 10 p.m. I want you to initiate a download and then initiate the reboot or whatever has to happen?
Yeah, we can do, there are some scheduled updates we can do, and we can do things like staggered reboots, no reboots. Another nice thing about our architecture is that whether it be the controllers or the APs, there's 2 firmware image slots on there. So, once you do the upgrade, it's an all or nothing thing. We can actually distribute the firmware updates, wait 3 months, and then reboot the APs, right? So we give you that flexibility even
You want to talk about the staggered reboot? I think that's kind of pretty cool feature that we have, right?
Yeah.
Being able to, so we can actually say, there's a feature called staggered reboot where when we push a firmware to a site, not all the APs kind of reload at the same time. So just to keep the services running at the site, we can kind of reboot the APs in a staggered fashion. So yeah,
so in other words, you guarantee that your APs get the new code and don't reboot, right? So once they all get them up, then you can launch and reboot whenever you want.
Okay, so I'm going to get Vic to talk about the auto AP provisioning feature and some troubleshooting tools. I wanted to show some CLI of the adoption, but I think it's I just ran out of my time.
We'll get to see some stuff.
Yep.